I guess one of the things I'm trying to do here is to, if I want to be dramatic about it, is give power back to the engineers, because I'm an independent software developer. I write software that I hope you'll buy and use, but I have to write the graphical user interface. I have to provide all the customization for it, and that's all you get. And there might be a little bit of customization in there, but there's not the kind of customization that can answer questions like what Rick was talking about, different kinds of problems. I have a full damage stability calculation program, and I was using it for Intech case, and I think it was an old ship that used to carry Army tanks or something. Somebody wanted to use it on the Great Lakes for carrying cargo. And I had to go through Coast Guard approval process, and as most of you know, there are different chapters and different paragraphs of which rules it has to meet. And I can't write a computer program that offers all of those rules of Coast Guard, ABS, ISO, what have you in there. I just can't do that unless the program got to be really, really expensive, and it's just not that big of a market. And what I had to do, and with my own code, is to, and the person wanted to know how much cargo can I carry and what is the highest vertical center of gravity of that cargo and still meet the rules. So I had to go into the rules to look at which subchapter, what was it was probably some area under the writing arm curve from 30 to 40 degrees or something. It had to be, above a certain GM. My code couldn't do that for varying the weight of the cargo and the vertical center of gravity of the cargo. I had to do that manually to change that and to go through and figure out what is the max VCG and cargo that could be carried. What I'm trying to do with this kind of a system is to say, well, I don't really have to worry about that. If I can provide a calc engine that, given the input values, produces all of the output results that you need, then you could go into a spreadsheet and do it yourself. That's not easy. You'd like to go out and buy a program to do it, but I just don't think that those things are ever going to be available. It just isn't justified by our market. So then the question is, what tools can we provide in a spreadsheet to make your life easier in terms of launching one or more independent calc engines that could be coming from any different source, but hopefully well designed and validated. And again, I'll disagree with Rick a little bit that the goal of this is not really to say this is going to be cheaper than going out and buying a real expensive package. I'm saying this is just different, right? So, and in fact, the people who provide those real expensive packages might say, I'm going to offer the big expensive package, but I'm also going to make calc engine versions of all of the calculations, so that my expertise is in, one of my major expertise is in hull definition using NURB surfaces. I can generate NURB surfaces, I can do hull variation of NURB surfaces, but I might not be so good with the CFD calculation or resistance calculation. So what I want to do is to encourage everybody to produce these calc engines, provide an open graphical user interface to analyze that one calc engine. Then the next step would be, what kind of classes of problems do engineers want to solve? And one of them is this sequence calculation. I want to run this calc engine, followed by this calc engine, followed by that one. And I think it's reasonably possible to have open, free software where you can pick calc engines, and I can write the software that goes in there and says, all right, I need to match up the output of this calc engine with the inputs of this calc engine, and then the results of this one go into here, and wrap it all together to come up with this combined calc engine. That's one higher level of class of programs. So you can list a set of calc engines and simply go in there and say, pick this one, followed by this one, followed by this one, and it could then wrap it all up for you, in theory. I talked about that before, input and output. I don't want to go over that again. So you have these different classes of solutions. You have one calc engine that you want to pass an input for and get output for. Do searches, optimization, or whatever on that one calculation. Then you have a class of calculations which is a sequence of calc engines. Whole variation followed by hydrostatics, followed by resistance or meshing, then followed by CFD. That's just a straight sequence. Another one might be a time step sort of class of problems where you can say, I want to iterate this sequence of calc engines, but with this time step, and then continue that for a certain number of time steps. Or it could be that you want to go through a series of time steps and then have the solution stop when it reaches a certain distance, or if you're plotting a course for a ship to take. It's going to go through this leg with these C conditions, and then it's going to go through this leg in this C conditions, and you want to be able to, perhaps you're going to run the same calculation over and over again, but with different inputs, but then combine them together. Nobody can write, well, I could write a program that could do that all for you, but you'd have to pay me a lot of money. But what I'm trying to push is this idea of individual calc engines that can be reused over and over and over, combined and mixed and matched together using open spreadsheet tools. And I really, in spite of what Rick says, I love spreadsheets. I'm probably one of the world's worst spreadsheet users, and I'm still somewhat of a newbie in terms of writing Visual Basic code, but I'm just amazed at what can be done. And in our small market, I think there has to be another kind of model for engineers to have available for them, instead of saying, all right, I can use a spreadsheet, but I have to somehow get the formulas and the code from everybody else to put into the spreadsheet myself. No, hopefully you can just collect calc engines from other places, automatically launch them, and your path toward a custom application solution will be done. So all of this is going to be available for you to download and to look at. And in the and it'll be on that website. I wanted it to be ready for download today, but it isn't. I have it on my USB stick, so if you harass me, I'll copy it, and you have a computer, or you can copy it over. But it includes the graphical user interface for the one calc engine. It will include 3 calc engines with this system. And let me digress a little bit. The goal of this is not to get SNAME into the business of paying for and developing computer software. Now, that doesn't mean that SNAME isn't going to do that. There might be old code, SMP scores, or whatever, lost code, lost child code, that people might have said, I remember this code from the 70s and 80s, and it worked great. Why can't we have it available? And if none of us independent software vendors we're kind of going, well, I don't really want to do that, then you can get other people to pay for those things, and SNAME can become a clearinghouse. What I'm hoping for this is to develop the standard and have SNAME provide the organization and the clearance house, and working with the TNR committees, working with other people saying, I really want to be able to do this sort of thing. How can we do it? And then we can work together to provide the higher level tools. And as an independent software developer with a son in college that I have to pay for, I really want to be able to sell calc engines. I'm not doing this for free. I'd like to be able to, it'd be a whole lot easier for me to write these calc engines. So if I have this Wageningen and V-screw optimization code, I can say, all right, this is great. I can wrap it up in a calc engine without too much effort because I don't have all this other programming to do. In fact, I did that with the download that's included in this is the Savitsky long form. It's something I wrote probably starting in the 1980s and had it well developed as a DOS application, never justified by converting it over to Windows. And using this technique, I simply started up Visual C++, created a batch application. I had a lot of the calculations in a separate library, all isolated anyway. All I had to do is just read in the input from a text file, call those routines to do the calculation, write it out into a text file. I'm all done. So that's included. So it includes an in-text, hydrostatic instability, Savitsky long form. Both of them do not include the source code, sorry to say, but it does include one full calc engine for doing powering of planing boats, the real simple formulas. And that is, I've included the full source code, the Visual C++ source code for that. You can look at that.
Can we throw it up to some questions?
Yeah, all right.
A little short on
Okay.
time. We do have this, and I'll just echo one thing you said earlier. At first computer programming thing I had to do was to write a script to do upper and lower case alphabets and numbers 0 through 9 using an IBM 360.
A 360, yes.
And if you don't think that
With a Calcom plotter, yes.
So, questions, discussion. I mean, I've heard a lot of things going on out in the hallway, so there must be something going on. Yes, sir.
So every calc engine, they have to rewrite the input, the code to read the input and write the output.
In the download,
To go any language. So
right, that's right. And it's a problem. I tried to keep the requirements simple. When I first did this, I thought that I would have as the input text file just a bunch of numbers, and that the person writing the calc engine would only have to read the one number per line. And then I started thinking, well, I really needed to use something like XML. And then I really didn't want to get that formal. It might end up heading that way, I don't know. But it ended up being a CSV, comma separated file format, name of the variable, like LOA for length overall, comma, the variable. Now in this download, I've included C++ code for reading those comma separated files. So if you're writing a program in C or C++, then I'm basically giving you all of the code to do the read and the write of that data. But if you're doing it in Visual, and actually in Visual Basic it's pretty simple, because Visual Basic has this command to read a line from a file that it has tools to automatically separate every single comma separated field, and you can pull off the third field of a comma separated file from a text file. But if you're doing it in some other language, then the person writing the calc engine is going to have to do that. But I'm hoping that all of us, engineers, people doing this, if everybody gets together doing this, then that's the sort of thing people will say, I have code to do that in Algol or whatever, Fortran, and somebody will provide it. And one of the things I've run into lately is that I feel pressure to, and I've been asked to write all of my calculations inside of a CAD program like Rhino. I really don't want to do that. The market is not that big. I would have to have my customers buy Rhino, learn it, and then buy all of my application programs. So what I'm saying is that a better solution to all of that is, I can't, even if I did that for Rhino, I should have to do that for SolidWorks, for Pro-E, all of these. I can't do that. So what I'm saying is you have this separate marine design executive that does all the calculations, that is completely independent. Then in each CAD program like Rhino or Pro-E or AutoCAD, and if you're doing a hull shape in there, then all somebody would have to do is to provide a special macro button that says dump the hull geometry, the current hull geometry from Rhino, let's say, into compatible database files. And I have a whole section in the paper about databases. I haven't even talked about that, but put it into a common database type format, assuming we can all agree upon what that format is. Then the independent calc engines can just read that. So if you're sitting there with Rhino, SolidWorks, or what have you, and you're designing your boat, and you have this special macro button, instead of having to write all of the calculations inside of Rhino or SolidWorks, you just hit the button, and if it dumps all the geometry out to standard other files, then you just pull up in a separate window the Marine Design Executive with all of your calculations, and you just hit the button, say go. It will read the independent data geometry, and you no longer have to write all of your calculations inside of a CAD program. They're all going to be separate.
I want to stop for a second, Steve.
All right.
The important thing to remember about all of this is that this system allows you to get in very simply, and I think you have to just show a simple example to kind of do it once to see what comes out, so people go, oh yeah, I can play with that, and you have that, right?
Yeah, that's
Okay.
part of the download. You start it up, you see the Marine Design Executive.
Just do it once.
Well, I don't have my computer. I just have slides here.
Oh, I thought you had it loaded.
No,
The
this
point
is not
this,
my-
Get the memory stick from Steve, and really what happens is...
Well, wait until next week sometime, then you can download it, and it's a full working system. I have instructions, and you can email me and say,
What I want to
what's going
stress
on?
is that if I were to get Steve's, what's your hydrostatics program called? It's a beautiful program.
Hydro 2A. That's
Hydro 2A. Okay, I buy that, and there's a price for it, and I get it, and I fire up Hydro 2A. My problem is I go, okay, yeah, there's buttons there. What do these buttons do? How do I deal with these buttons? So I buy it, and I have a 4, 5, 6, 7, and you know, God forbid, I might even have to read his manual. What happens with this particular system is that you get it, you push a button and kind of go, huh? Well, wait, still a spreadsheet. So you kind of start to pick around the spreadsheet, and you realize that you're looking at a spreadsheet, that there's a calculation. But what it's not is somebody else's spreadsheet, if that makes sense. There are too many great computer programs that were written in spreadsheet format that are somebody else's spreadsheet, and every time you click on a cell, there's an equation behind it, and you have to figure out what these equations are and whether they make sense. The spreadsheets that you get in this system are simply input and output data. There are no equations in the spreadsheet. Does that make sense? And this is what the whole thing is, so you get the data that you can manage, that you move around. That's the important thing.
I just want to make one more comment in terms of the split between the computer-aided design program and the calculations. Is that the holy grail seems to have been up through now is to have your computer-aided design program, as you're tweaking your NURB surface, you want to say, oh, what's going to be the resistance of this, or run it through a CFD analysis. You want to hit a button, generate a mesh, go to another analysis program. But those are all interactive, manually done. You have to do that. When what you really want to be able to do is automate all of that. You want to take a hull, a parent hull, or automatically generate a hull, go into the calculations or generate the mesh and do the calculations and go back and search a design space. And it's really not an interactive type process. You want this all to be independent. I got a call a few weeks or a month ago or so from somebody who had done a automatic sailboat hull generation in Pro-E and wrote some macro code for it, and it could do hydrostatics and it would balance on something. I don't know what the code is. And then he wanted to, then he would have to manually go and generate a mesh that he put into David Egan's Flow Logic CFD program. And he was manually going through the search of good designs or whatever, but he wanted to automate all of that. And he said, well, what programs do you have to do that? And I said, gee, we have this new system which could make it all automatic. If he could write his own calc engine to do the whole generation. And actually it was really pretty nice, but he probably kept it private, but he could write that, go into my hydrostatics, then go into somebody else's flow code.
And on that high note,
All right, low note.
sorry